Hello everyone, this is Issa Ramaji. First of all, I want to thank the award committee for granting me this prestigious award. I'm truly honored to receive it. My research was on tra- automating transformation of building information models to engineering analysis models. So based on the research done by McGraw-Hill, the value over difficulty ratio is low in engineering BIM uses, especially in structural and energy analysis use. Uh, I found two main reasons for this problem. One, interoperability issues, and two, interpretation that are required after a BIM model is imported into an analytical tool. So I work on developing a mechanism for automating model transformation um, in between BIM and, and analytical tools using open standard file formats. So in this mechanism, we get information in IFC files, building information models in IFC files, do the interpretation automatically, and generate another IFC file in another analytical view. So, to be able to design such a interpretation engine, we need to break down the work, break down interpretation into different units. Those units are called interpretation units in this research. So I work on developing a methodology for design of these units. I try to keep it consistent with IDM MVD development methodology. So it has three layers. One is concept layer, in which we generally define the purpose of the interpretation unit. A generic layer in which we list all the input and output information of that unit. In some units, we need some additional information from external sources. For example, if this unit is interpreting mechanical properties of structural materials from their name in BIM file. So we need to have access to a table of mechanical properties of those materials. That could be a code, that could be specifications from manufacturers. So we need to document those external sources in this layer. And in IFC layer, we bind these information to IFC data structures. Uh, IFC data structures. So this is similar to what we do in MVDs. So I did a case study to test this idea and to validate it. So I work on developing a tool and mechanism for transformation of building information models to a structural analytical model. So it has 5 units. One unit, which is called direct unit, no information is being changed. So project and unit system information, special objects and their aggregation, we don't touch those information. We just directly exchange them to the output file. So, but in other units, which are IU units, which are interpretation units, we do some changes, transforming linear elements, transforming planar elements, adding mechanical properties of the structural materials, and adjusting coordinates to do connectivity to resolve the connectivity issues. I will go through this one in more detail to provide an example for IUs. So in views such as coordination view and design transfer view, we represent elements, physical elements, by the by the amount of space they occupy. So if you have a beam connecting to a column, we don't continue beam to the center line of the column. We just continue that right to the surface of that column. But in analytical view, such as a structural view, we represent beam and columns by lines, and those lines are connected to an identical point, points that are connection points. So I developed an algorithm that find the coordinates of these elements, calculate the distance between these elements, and compare that distance with size of those connecting members, and based on that, identify the connection points, and according to that, adjust coordinates of these connecting members to have them connected in one identical point. So I use these IIE mechanism and develop a tool based on that. So this model is showing a billing information model in Revit. I'm going to export it into coordination view. So I'm importing that model in SAP, CSI SAP. As you can see, the model is broken because of the connectivity issue I just talked about. They are not connected. Now this is the tool I developed. So I'm going to import the IFC model in coordination view and exporting another IFC model in a structural view. Now I'm going to import the newly generated IFC file in SAP. And as you can see, the coordinates are adjusted automatically, and we have a integrated model, structural model. So to further test this model, I used two of the test models provided by Building Smart Alliance. So this model shows the analytical model before being without interpretation. I mean, this is just importing the IFC file in coordination view into SAP, and this is the model that was interpreted by the tool I developed. So IIE can change the way we exchange information. So right now we expect BIM authoring tools to implement all the MVDs that are available for different BIM uses. But using IIE, we can just expect BIM authoring tools to export the model in a MVD, which could be a master MVD. Master MVD could be design transfer view or coordination view, and then create IFC files in other views from that master MVD. In this way, we can significantly reduce the burden of implementing MVDs in BIM authoring tools. Thank you very much for attending my presentation, and I thank the committee again for granting me this award.